Hi everybody and welcome to another video. My name is Torke Petersen. In this video I will show you the first steps using Qt display development inside Guide. Please have a look to the other video PLUS+1 Guide and Qt overview number 180 as well, which shows the features and an overview how to integrate Qt in PLUS+1 Guide. In the following I will go first through the minimum requirements and how to install Qt. Then, using an example, I will show the individual steps of Qt display programming inside Guide. Since the Qt framework has been implemented to the Guide version 2024.2, this is the minimum software version needed to use Qt in Guide. It also requires specific Qt HWD version for the display hardware, which supports Qt. There are different ways to get Qt downloaded and installed. You can download it directly or from your Qt account. Go to the Qt group homepage, choose and download the Qt online installer and go through the installation process. For this video, only Qt Design Studio is needed. Before we start, create a new Qt project in Qt Design Studio. We will have a look into Guide and my example display program. I have a simple display project which has originally been used for the DM700 and vector-based screen editor. For the Qt project, the DM700 Qt HWD has been used and the component Qt QML interface has been added. All needed signals are connected to the input bus, like the Boolean signals from the HMR to select menu items, main, info, and settings. The date and time signal, which has been converted from unsigned integer to a string signal, a simulated signal for the gauge rotation, and the power voltage from connector 1, pin 2. From the output bus in my example project, there is a signal called backlight new, which is used to control the backlight of the DM700. All these connected signals act as input and output in the Guide and Qt interface. Like it has been shown in video number 180 already, the Qt component has some limitations for the input and output signals. Qt-related limitations like types. The component allows only types bool, S32, string, and floating F64. So if different types than these listed are used in Guide, they need to be retyped first to one of the allowed types, like it is done with the power voltage signal in the example, which is originally unsigned 16 and retyped to an signed 32, so that it can be used in Qt. The inputs and outputs in the Qt interface are bound to the backend through a Qt object called _p1 based on +1. This Qt object _p1 is registered to the Qt QML engine at startup and contains two Qt property to read and write, _p1.get and _p1.set. These properties are defined by name, for example, _p1.get.speed. The default data type is an integer, so an S32, and the data type can be defined by Guide data type prefix, for example, _p1.set.real_speed. Another limitation for the component Qt QML interface is the signal names, which must start and end with a minor character. Based on my example project, let's take the Guide signal date_time with the data type string. Due to the limitations, the data type string is supported and don't needs to be retyped, but the signal needs to be renamed since it must start and end with a minor character, so I called it date_time. This input signal can be used in Qt via the Qt object _p1.get.string_date_time. The object _p1 get or .get to read an input signal, and .string_datetime, the defined name and data type prefix. I will show it in the following how to use this binding in Qt. But once again, as you can see, the mentioned limitations, any signal name starts and ends with a minor character. And if the data type does not match one of the supported ones, it needs to be retyped first. That's all you need to consider inside Guide using the Qt QML interface component. The last step in Guide is to link the Qt QRC file to the project manager, but before I do so, I need to create the Qt project first. After I downloaded the Qt Design Studio via the download link shown before, I started and select Create Project. During this step, it is important to choose the correct target Qt version, Qt 6.5, since this library is used in the current display HWD. In addition, you can select the needed presets and style and do some settings like project name and path, and in my case, the correct resolution based on my example display DM700 with 800 and 480 resolution. Before I go through the steps to develop a Qt display, I will show how the display screens should look like and what data are shown. For this first Qt project example, I will show some use cases like a state machine, so switching from one page to another, a gauge edit with images at needle rotation, which is similar to the vector-based screen editor in Guide, and show how to use data from Guide inside Qt Design Studio and also data sent from Qt and read in Guide. First, I create default screen page and reusable component. In the default state, I add 3 buttons from where I can switch to the different pages. The main button to switch to the main state, the info button to switch to the info state, and the settings button to switch to the setting state. Second step, create screens. Now I will create new states for each screen, main, info, and settings by clicking on the plus icon. Each state will get a unique ID. Step 3, create state machine. After creating states, I need to connect the buttons to the respective states so that if the button has been clicked, the respective state or the page will be visible. Under connections, I create new ones for each button, starting with the main button. Select target button main. The signal will be clicked and the action is change state. For the state setting, I select the main state. I will do this for the button info and settings as well. Now my state machine is ready. Instead of display buttons, also external signals can be used to navigate through the menu. My guide project includes HMR, where 3 buttons are connected to the Qt interface. So instead of the 3 display button, these 3 CAN signals can be used to navigate through the menu as well. To add this in Qt is quite simple. First, I create Boolean local custom properties and set the binding to the input signal, which, or with the coding underline p1.get underline bool underline the selected state. Then I do the same like I did for the display button, create connections for each signal. But instead of selecting the button as target, I have to select the screen itself. This is necessary since the input is not a visible element on the screen. Since I will use the date and time on each screen, I add this to the default screen as well. The date and time will be read from the guide code in the data type string. To connect the text component, I will do the following. Select the text component and go to Properties. I click on the icon next to the property text in the tab Character and select Set Binding. Via this binding option, I assign the input signal date time provided from guide to this text component. I add the needed interface code for inputs, which is underline p1.get, followed with the data type string or dot string and the interface signal itself, which is underline date time. If you remember from my guide code, I've added the date time variable to the Qt QML interface component as an input signal. All input signals in that guide interface can be read inside Qt with the underline p1.get. This is one option. Another possibility is use local custom properties like I did for the HMR button already. First, I select the text component and go to Properties. In the tab Local Custom Properties, I add a new property called DateTime and set the binding to the input interface signal DateTime. This option creates a new property which is selectable for other components via, in this example, text1.datetime, which is more flexible to handle. So I go to my text component in the tab Character and set the binding. But instead of adding the input interface code here with underline p1.get and so on, I select the previously created local custom property text1.datetime. To show a predefined value for the date or for the properties in general, I use the following code. Via this code, the input signal of the guide interface will show this default value as long as it is underlined. So in this example, it is the year 2024, followed with the day and the month and the time. As you can see, the component is visible on any state, so in main, info, and setting state as well. In this case, it's fine, but if you want to add different components to each state, a loader is needed, which is shown in the following. Step 4, component loader used for enabling different screens. The Qt component loader can be used to make the screen or components visible. In my case, to show different screens like the main info and settings page with different components. Like different QML files, which can be copied to the loader and loaded if necessary to make the screen or components visible. I select the loader component and drop it into the navigator tree. Now the loader component is part of my screens. Next, I need to create a QML file for each screen. This QML file will represent the respective screen for main, info, and settings with its unique and own visible components like text, gauge, and so on. I go to the component content folder under project and right-click and select Add New. I choose the Qt quick file, which creates a component file, so a .qml. I do this for main, info, and settings. Please check that each QML file has the correct resolution for the selected display. As you can see, you have the 3 new added QML files in addition to the already existing ones, app and screen 1, which is the default screen. Now I need to define the screen for the loader for each state. So I double click the screen 1 QML file and select the first state main. Select the loader component and go to the source property in the tab loader. For the first state main, I select the source main.qml. I do the same for the info state and setting state as well. Now the new added screens has been assigned to the respective state and the needed components can be added to each screen. So any change or added component on each screen will be shown on that state only. Number 5 or step 5, adding components to each screen, starting with the main page. On this page, I want to show a gauge displaying the value of the guide input signal gauge rotation. I add this gauge in the most easiest basic way, similar to the steps needed for the vector-based screen editor and guide. I know there are many gauge widgets and applications available on the Qt forum or internet platform. This example is just to show you the connection of the provided guide signal inside Qt Design Studio. I open my main.qml file and add the image component. I select the gauge image under source and do the same for the needle image. To set the rotation point of the needle, I select the needle image and go to Geometry 2D under Properties and select the bottom center under Origin. Next, I create a local custom property, call it gauge rotation, and connect the guide input signal to that property via set binding. As undefined value, I set it to -75, which is in my case the zero area of the gauge. That's it for the main page. On the info page, I will show the voltage supply value. For this, I add three text elements to the info page. The first text component, I just add the text manually as supply voltage. Also, the third text element with millivolt. The second text element in the middle will show the input signal from guide called supply voltage. To do so, I create a local custom property first and set binding to the input signal and the undefined value of 0. Now it is more convenient to assign the local custom property to the second text element with info.supply voltage. On the last page, settings, I add a slider element which should set the backlight of the display. I drop the slider element inside the settings.qml file and also add a text element which should show the current slider value. For the slider, not much settings are needed. I just set the range from 0 to 100 and the step size to 1. For the text element, I set the binding to the slider.value property so that the current slider value is shown on the screen. That's it from the visible point of view, but the slider value should be used in guides to set the background light of the display. So it needs to be set as output for the guide interface inside Qt. To do so, the binding function needs to be added to the code with the target underlined P1, so the Qt object, the property, the set.integer underline backlight new, and the value itself, which is in my case slider.value. With this coding, the slider value will be provided as output signal with the name backlight new in guide inside the output bus of the Qt QML interface component. The Qt display programming for this first step example is done. Just a short summary of what I showed. I created states and different screens, so a state machine managed via buttons. I added different display elements on different screens with signals from the Qt input and output interface. The Qt inputs needs to be defined as underline p1.get, followed by the data type and the signal name. The signal name has to start and end with a minor character. So for example, underline p1.get dot string underline date time, where the underline p1 means look to the Qt object underline p1, which is a +1, and read, so the dot get, the variable with the data type string and the name date time. Inside guide, the signals are connected to the input bus of the Qt QML interface with the same naming and lowercase character. The Qt outputs are defined by using the binding component, and this component provides three parameters. So the target, in our case, it is, or in my example case, it is the +1 target repository underline p1. The binding property set.int underline backlight new. Dot set will define the variable as output signal. Integer defines the data type, or int, and backlight new the signal name. The binding parameter value defines the source of the signal name. In this example, it is the value of the slider component. Back inside guide, all defined output signals are provided in the output bus of the Qt QML interface component. The last step is to generate the QRC resource file and add it to the guide project. The Qt resource file is a platform-independent mechanism for storing binary files in the application's executable. This file does include the display development created with the Qt tool with all the icons, images, buttons, menu selections, and functions shown on the display. Inside guide, the Qt QRC file will be added and the component Qt QML interface acts as the input and output interface to the Qt development file. Like it is shown in my example, connect the guide variables to the input bus using the correct name and also read the output signals like the backlight new signal, which is used for further guide coding to control the backlight of the TM700. Compile the guide project and download it on the display using the PLUS+1 service tool. We hope that you found this video useful. Remember that PLUS+1 community help is available on the PLUS+1 user forum. Check out other videos on our YouTube channel or contact the PLUS+1 help desk. Thank you for your attention.